Welcome to anyone tuning in to video 1 of our Functions and Equations unit for IB Math HL. In this video, we'll be going over 4 questions that help apply knowledge to exam-style questions. Now without any further ado, let us move on to question 1. For question 1, we want to find the domain and range as well as to sketch the function. Firstly, we'll rearrange the function into vertex form by creating a perfect square quadrilateral. Keep in mind that the negative 9 over 16 will be multiplied by negative 2 when we move it outside the parentheses. Once this is done, we should be left with a vertex of 3 over 4, negative 31 over 8. Next, we'll find the y-intercept of the function by substituting 0 into the x's and get negative 5. Once we have the following information, the domain can be stated as all real numbers, and anything under negative 31 over 8 as our range. The sketch can be seen below with the y-intercept and vertex points labeled. Question 2 gives us two functions, f of x and g of x. The question asks for the domain and range as well as a sketch of the function f of g of x. Firstly, when writing out the function f of g of x, we can identify that the function is already in vertex form. Hence, we can instantly find the vertex, which is located at point negative 3, 5. After finding the vertex, we will find the y-intercept of the function. This can be done by substituting x with 0. In doing so, we find that y-intercept is 23. With this information, we can deduce the domain and range of the function. The domain of x will be all real numbers, whilst the range will be y is greater than or equal to 5. A sketch of the graph can be seen to the right. Keep in mind to annotate the important parts of the graph, such as any intercepts or specific plot points. Question 3 moves on to translations of an already existing function that is given to us on a graph. Firstly, we'll find the domain and range of the original function, so we can apply the given stretches and translations. Then, we can start by finding the new domain of the function by applying the appropriate changes. The minimum domain will first translate to the left by 1, and then stretch by a factor of 3 to get negative 7. Repeat the process with the maximum domain by once again translating left 1 unit and stretching it by 3. Thus, we'll find our new domain to be negative 7 is less than or equal to x is less than or equal to 6 over 5. We'll find our new range by doing the same thing. However, this time we'll stretch by 2 first, and then translate it downwards 2 units. This will leave us with a new range of y being in between negative 10 over 3 and 1 inclusive. Finally, question 4 asks us to find the inverse of function f and graph it. In order to find the inverse of a function, we will rewrite the function as a y equals equation and switch the x's and y's and solve. Through a process of factoring and expanding, we will be left with a new function, f inverse of x, which equals x plus 6 over 3x minus 5. Once we have our inverse function, the y-intercept can be found by substituting x with 0 and find negative 6 over 5. The x-intercept can be identified by finding when the numerator equals 0, in this case negative 6. However, we have another step we need to consider when working with a function as a fraction, asymptotes. Asymptotes occur when there are no defined values for a function. Therefore, a vertical asymptote will be located when the denominator of a function is 0, in this case at x equals 5 over 3, since a fraction with 0 as its denominator is undefined. We can also find a horizontal asymptote if the original function had a vertical asymptote, in this case 1 over 3. With this, we can now draw a sign diagram which will help us sketch the inverse function on a set of axes. Making sure our graph abides the sign diagram and asymptotes, a sketch of f inverse of x can be drawn like so. Hence, our new domain will be all real numbers except 5 over 3, and our new range will be all real numbers except 1 over 3. And there we have it, 4 exam-style questions on functions and equations. If you found this video helpful, please feel free to see some of our other content explaining IB math or physics through our channel. Thank you for watching, and we'll see you next time.